Raycasting, a programming technique that finds anything along a predesignated line. Originally invented to replicate how light travels to provide more realistic lighting, it is now used for virtually everything. For example, raycasting can find obstructions along the path of a bullet. To understand how it works, consider your program's viewpoint. You don't know what is around you, but you know where you are and what direction you want to move in. So, you stick your finger out and walk along your path. If you touch something, it suddenly lights up in front of you. When something is found, you get to know what it was, where the raycast intersected one of its faces, and the normal of the face it intersected with. Let's say you want to make something that reflects off anything it interacts with. To start, let's make an object. Now let's add an attachment to the object. Next, add a linear velocity. Make attachment 0 in the linear velocity of the attachment we just made, and make the max force constraint a really big number. Next, go to vector velocity and add the starting velocity you want. Now, create a script inherited to the object. Allocate a variable for the object the script is inherited to, and one for the linear velocity. Next, add a .touched event listener for the object variable. This event provides a variable for the object that touched our object. Now comes the raycasting. Create a raycast params object. Set filter descendant instances equal to that table. Finally, set its filter type to enum.raycastFilterType.include. All this does is make it so the raycast can only find parts inside of the filter descendant instances table. Now create another variable and make it equal to our raycast. We want the raycast to start with our position, go in the direction we are moving, and have the line be a length equal to the magnitude of the size of our object. Finally, make the last parameter the raycast params we made earlier. If the variable is nil, for this example that just means there was nothing directly blocking our object. To find the reflected velocity, take the normal of the face the ray intersected with, and the normal of the linear velocity.vector velocity, and plug them into this function to reflect the vector. Next, get the magnitude of the linear velocity.vector velocity, multiply the reflected normal with the magnitude to get the new velocity, make linear velocity.vector velocity equal to the reflected velocity, and make our object's assembly linear velocity equal to it as well. If you enjoyed, please consider liking and subscribing. That's about it. See ya.